Okay, for the last problem, for the last video, we will see two word problems. I'm trying to find them here. Okay, they are on your handout, but I don't have the problem statement for the second problem. So you have a similar one on your homework. So I'm going to share my screen here. And we'll look at the first problem. It says the length of a rectangular garden, so a rectangle, is 6 feet longer than the width. Okay, and I'll show you how we take it from the problem statement, how we take it to the given values on the notes. Okay, if the area of the garden or the area of this rectangle is 27 square feet, find the length and the width of the garden. Okay, that's what we're going to do first. Maybe last, because I don't have the problem statement of the other one, but I'll try. Okay, I'll try to remember it. Okay. All right, there we go. This is the first problem. Should have left a little bit more space, but I think might be good. Okay, we have a rectangle. Just let's pretend this is a straight line here. And we have the length and the width unknown, but we know that the area is 27 square feet and that the length is 6 plus the width. Okay, so with that, we can find L and W, or we can attempt to find L and W. So I wrote down what was given and what we need to find. The area, as we may remember, is L times W. And that's one of our equations. And we know that L is 6 plus W from what's given. So this equation can turn into 6 plus W times W, or 6W plus W squared. That's what I have for the area. And the area also given, and I'm highlighting up here, is equal to 27. 27 equal to 6 W plus W squared. So I'm going to highlight this in a different color. This is one of the equations that I can find from our knowledge of the equation of area and what's given in the problem. Now, do we have anything else that's given? No, I highlighted everything. So I have 27 equals 6W plus W squared, and that's it. Now we look at this and we're trying to figure out which method can I use here. There's no greatest common factor. This doesn't look like one of those special cases of a squared minus b squared. And so I'm going to try to make this equal to 0 and see what happens. Okay, so I'm going to move some things around. W squared plus 6W, what was on the right hand side already, minus 27. Okay, I'm making this equal to 0, or if it makes you feel more comfortable, making it equal to 0 on this side, it's the same thing. I subtracted 27 from both sides. But now I try to factor this, find the prime factorization. Numbers, or two numbers that add up to 6 and multiply to negative 27. Okay, so this is, again, I'm not writing that down, but this is what I'm doing. Looking for numbers that add up to 6. Yes, add up to 6 and multiply to negative 27. So I have negative 27 and 1. Does that add up to 6? It doesn't. What about negative 9 and 3? That add up to negative 6. So I'm close to negative 3 and 9. Those two numbers, my apologies here, those two numbers, they do add up to 6, and we can multiply them and get negative 27. Therefore, I can factor 0 equal to W squared plus 6W minus 27 as 0 equal to W minus 3 and W plus 9. From here, values that make that true are W equal to 3 units and W equal to negative 9. But this W equal to negative 9 physically doesn't represent anything for this problem, because we're looking for width and looking for length. So W equal to 3 feet will be the answer for the width, and then the length, right? We know that the length is 6 plus W will give us that the length is 9 feet. Okay, so again, when we get these negative numbers as a second solution for a problem where we have this physical representation, then we want to be careful with that. The second problem, and I might not finish the problem here, is similar to a homework problem where we say that there are a number of people in a room, and based on the number of people in the room, if each person shakes hand with every other person just one time, there will be S number of unique handshakes. So again, I'm in this room, and then we we can have 2 other people join me here, like Brad Pitt and Shaquille O'Neal, and then we can calculate how many times we can have unique handshakes if we shake each other's hands just once, okay? But everyone else's hands. So the equation will be S equal to P squared minus P divided by 2. That is given. And there are two parts for this problem. For the first part, we want to solve what happens when P is equal to 6. So we can just substitute that into our equation to find S. We have 6 people. How many unique handshakes we can have? P squared minus P equal to 2. We have 6 squared minus 6 divided by 2. 36 minus 6 divided by 2. And this is 30 divided by 2 equal to 15. So if we have 6 people, we have 15 unique handshakes. Now the second part, a little bit more difficult to calculate. If I have 105 unique handshakes, how many people do I have? So in that room or that place, wherever they are. So I substitute into the equation that's given up here, okay? And I'm going to see what happens. I have 105 equal to P squared. I don't know if you hear them. Minus P divided by 2. I'm going to continue manipulating this equation. I'm going to multiply by 2 on both sides. And see what happens. I have 210 P squared minus P. And it's similar to the previous problem. I can't find a greatest common factor. It doesn't immediately look like a special case. So I'm just going to make this equal to 0 and see what happens. P squared minus P minus 210. And this one is a tough one in order to find those 2 values that add up to -1, because we know that B is -1 and C is negative 210. So here, if I start looking for the factors, I tried out 7 and 30 or -30. I know that's not close. I tried out 10 and -21. Even if I flip the signs, that's also not close. So it took me a while using the calculator to find that it was -15 and 14. Okay, so it does sometimes take a while, and that's fine. That's part of the process. So I have 0, P minus 15, P plus 14. The 2 values that can make this equation true are P equal to 15 and P equal to -14. But P equal to -14 means -14 people in the room, and that again doesn't have any physical meaning. So P equal to 15 would be our answer. Thank you for watching. Assuming you watched, well, you got to this part of me thanking you, then you did watch, so thank you for watching. And no waving, no waving.